Welcome to Kojo's Pre-Algebra. Okay, so I hope you've read your section that you were supposed to do, and you should be able to tell me what a coordinate plane is. Tell me what a coordinate plane is. That's right. Okay, you should be able to tell me what an ordered pair is by this point. An ordered pair is x and a y. It's a point. It represents a point on a graph, and the first value is the x-coordinate, identified with the x-axis, which is the horizontal line. The vertical line is the y-axis, and the y-coordinate is the second point. So you go across on the x-axis and up on the y to plot your point. So what we're going to focus on right now, you found out what relations were when you read the section. Relations are what? Can you tell me? That's right. Relations are a set of ordered pairs, a whole bunch of ordered pairs. And in the relations, there's two parts to it, the domain and the range. The domain are all the x-coordinates, all the values associated with the x-coordinates, and the range are all the y-coordinates. Simple enough. You need to know that. Domain is always associated with the x-coordinates, and range is always identified, I had a brain freeze, identified with the range. So let's look at this. A relation is any set of ordered pairs. Okay, you notice here I have a set of ordered pairs, and I've graphed them, 1, 1, 2, 1, 1, 4, and 3, 3. And there it is. There's the graph of those 4 points, and that's called a relation because it's a graph of ordered pairs. That's how they relate to each other on the graph. Then I have a set over here. This is also a relation. 1, 1, 2, 2, 3, 3, and 4, 4. And it's a straight line. But this is a relation. So any graph of any set of ordered pairs are a relation. Then you have to identify if the relation is a function. What is a function? A function is a special relation where each member of the domain, what the domain is associated with which coordinate? The x-coordinate, correct. With each member of the domain is paired with exactly one member of the range. It's kind of hard to see. One member of the range. So you have a member of the domain, the x-coordinate, paired with one member of the range. Simple enough, it sounds like. It gets a little tricky though. So functions are relations. Remember that. All right. So what you do is you have to be able to do a mapping diagram. Okay? A mapping diagram is where you take apart the coordinate points and you break them into the x-coordinates and the y-coordinates and identify them as the domain or the range. So here we have 4 points. The x-coordinates are 2, 4, 6, and 7. So this is the domain. It's always written on the left side, the domain, because you input the domain to get the range. So the next one is the range. It's always written to the right. That's how you set it up. The domain is on the left, the range is on the right. So we draw an arrow from the domain to the member of the y-coordinate in the range. So see 2, 5, 2 goes with 5. You want to write, you got to be able to do this. This is called mapping. So now we do 4, and we're going to go 4 to 5. Because that's 4, 5. Then we have 6, 6, and we have 7, 8. Okay? Now, this is still, this x-coordinate, the 2 from the domain, is paired with only one range, one y-coordinate, the 5. Now we have a different x-coordinate, 4, and it's paired with 5, but it's a different x. So that x is still only with the 5. So hold on to that thought. This is a function. This is a function. Now let's look at this. We have 1, 3, 9, 15, and 9, 8. I'm going to write them in numerical order. So my domain is 1 and 9. I don't write 2 9s because I have 1 9. I already have a 9 down there. So then I have 3, 8, and 15. I put them in numerical order. I map them and I identify it. So the 1 goes with the 3. Now, this 9 goes with the 15, and it goes with the 8. So that is not a function because it doesn't meet the definition of function, okay? To be a function, the member of the domain can only be paired with one range. So this is 2, 5. This 2 from the domain only has one value with the x, y coordinate, and that's a 5. Now the 4 is in the domain, and it's also with the y coordinate, but it's a different domain. Remember that. So this is a function, and this is not a function because the domain, the x-coordinate 9, has 2 different values for the y-coordinate from the range. Okay, how do you determine it if it's a graph? So it'll be a little bit easier to see. So these are both relations. We have to determine if they're a function. Remember, is this a function? Because for every x, I can only have one value of y, one y-coordinate. Well, look, it looks like it. And how could you tell? Besides looking at it. It's called the vertical line test. Because if I have one x coordinate, and I have it identified with 2 different y's, like I did before, which was what, 9 and 8, 9 and 15, look what happens. Let's just go 5, 10, 15. So right about here is 9, right? So we got 9 when x is 9. Y was 8, so let's say it's about right here. And when x was 9, it was also 15. See how it stacks on top of each other? It won't pass a vertical line test now. That was from the previous function, the previous relation that we determined wasn't a function. When we go across, there's an intersection with the vertical line. Therefore, it is not a function. Now, if I take that out, because that was just an example of the relation I gave you that was not a function to show you how it works on a graph, does this pass a vertical line test? Yes. There's only one point of intersection on the vertical line at any one time. There's nothing stacked on it. So this is a function. What about this one? It's skipping all over, but there's nothing that indicates that the x-coordinate has 2 different values of y. So look, see, vertical line test, there's no second point of intersection. That one's close, but it's not. Comes across. So this is a function too. All right, what about this one? You go across. Oh boy, that's a vertical line being intersected by a vertical line. That's not a function because x has all these different values of the y-coordinate. So you got 1x, which we would say is about, we could call that 2. When x is 2, y, so you have the point 2, 2, 1, 2, 3, 2, 4, 2, 5, 2, 6, 2, negative 1, 2, negative 2. See, y is all these different values, but you only have one x-coordinate identified. So you have one x-coordinate, and you'd have 1, 2, 3, 4, 5, 6, 7, 8 different coordinates with that one x. So it's not a function. What about this one? You do the vertical line test. That fails. That's supposed to be on top, directly on top. So there's one x that has 2 different values of y, so therefore you can say, oh, it's not a function. That's it. You should be able to tell me now what the difference between what relations are, and then how can you tell if a relation is a function? Now you may say, why? Well, that's coming. You have to trust me, and you have to know that I can't give you that information yet. Come to class, write down 2 things that you learned from the reading or this video lecture, and 1 question you still have. And I will see you in class next time.